All right, hi, my name is Marcus Suzuki, and today I'm going to be going over the axis of symmetry. So remember, the axis of symmetry is a line that separates the left part of the quadratic from the right part of the quadratic. For example, here's a quadratic, right? So it's always going to go through the middle, and you can clearly see that the left half and the right half are completely symmetrical, and the line in the middle, or what's called the axis of symmetry, okay, is the line that separates the left half from the right half. So that's what we're going to be focusing on today. And the axis of symmetry is always in the form of x equals, okay? So you want to be able to understand it's always in the form of x equals. Okay, so I'm going to erase that real quick. Let's look at a general overview of the three graphs that we have. The first graph is in the form of it's in vertex form. That's the equation. The first equation is vertex form. The second equation is in standard form, and the third equation is in factored form. Now, no matter which form we are using, we always want to identify the vertex first, because remember, the whole goal of this video is to be able to understand how to get the equation for the axis of symmetry, which is always going to be in the form of x equals something. Okay. So for the first graph, if we identify the vertex, we're at the point 2, negative 1. Okay, pretty simple. I just identified the vertex. Remember, the vertex is always the highest or lowest point of the quadratic, okay? Let's look at the second vertex. That's going to be at the point 1, negative 1. And on the third graph, the vertex is at the point 1, negative 4. Okay, so just drawing out the axis of symmetry is pretty easy. It just goes directly through the middle. So I'm going to draw all three axes of symmetries right now. So the first axis of symmetry is going to be right here. Second axis of symmetry is right here. Third axis of symmetry is going to be right here. Okay, so that was pretty easy. Remember, the axis of symmetry just literally separates the left half from the right half of the quadratic. Okay, now the goal is to get the equation for the axis of symmetry. What is the equation for the axis of symmetry for problem number 1 right here? The equation for the axis of symmetry would just be x equals 2. It's always in the form of x equals the x coordinate of the vertex. Okay. What about for the second graph? For the second graph, we're literally just looking at these 3 points right here, which are all the vertexes. And we're pretty much almost recopying the x coordinate, the value in the first spot of the vertex, okay? So the equation here for the axis of symmetry is x equals 1. Okay, if you notice here, I just recopied the x coordinate of the vertex. And for the third graph, the equation for the axis of symmetry is also x equals 1. Okay. All right, so if you notice here, the x coordinate of the vertex for problem number 1 is 2. And I just recopied that right here. The x coordinate of the vertex for problem number 2 is 1. And I literally just recopied that right here. And the x coordinate of the vertex for problem number 3 is right here. And I literally just recopied that here, where all 3 of these equations, here, here, and here, what are all of those? I'm going to group them all at once. All of those equations are what? Those are all of the equations for what? For what? Those are all the equations for the axis of symmetry. Okay? Axis of symmetry. So the equation for the axis of symmetry for problem number 1 is x equals 2. The equation for the axis of symmetry for problem number 2 is x equals 1. And the equation for problem number 3 for the axis of symmetry is also x equals 1. Okay? Remember, the equation for the axis of symmetry is different than the equation that indicates the quadratic that we have. So if you notice, we have 3 different equations that describe the 3 different quadratics. But then we also have 3 different equations that describe the axis of symmetry on the bottom. Okay, so just want to make that clear. So drawing the axis of symmetry isn't that hard for the quadratics because you just go right through the middle, and understanding what and getting the axis of symmetry for all three graphs is also not that hard because they are all in the same form, x equals. And for the axis of symmetry, we just identify the x coordinate of the vertex and we recopy it on the right side of all of these three equations that I have, okay? So that's not that bad. Now the challenge is to get the same results, okay? So the goal is we want to get this equation here. We want to get this equation here. Remember, all these equations I'm circling are for the axis of symmetry. And what we want to do is we want to recreate those equations, not by using the graph, but by just using only this information from these three forms, the vertex form, the standard form, and the factored form. So that's the goal. Let's get the three equations for the axis of symmetry and pretend we didn't have the graph and we only had the equations on the top. So how would that look? Okay, so let's see. So I'm going to do the first one right here. From the equation in vertex form right here, it's easy to get the value of the vertex. So the vertex is just the opposite of what's on the inside of the parentheses. So I can identify, okay, it's just going to be 2, -1. That's all it is. And remember, that's the same point that I got here from the original graph. And then once we identify the vertex, I can just identify the equation for the axis of symmetry, which is just x equals 2. So number 1 is the easiest one to do with just the equation. In this case here, the equation was in vertex form. Okay, so how do I do number 2? Number 2 is in what we call standard form. So this is the number 2 equation I'm looking at. And standard form is y equals ax squared plus bx plus c. So this is the key concept where you really have to pay attention now. So in order to get the equation of the axis of symmetry for any quadratic that is expressed in standard form, we want to use x equals -b over 2a. That's the important equation for this topic. So for problem number 2, we need to first identify what is a and what is b. So for problem number 2, I notice that a is 1 and b equals -2. So what I'm going to do is I'm going to plug in those two values into this equation right here, and I'm going to get the exact same equation for the axis of symmetry on the bottom for problem number 1. I already know the answer should be x equals 1 from the graph, but I'm also going to get the equation for the axis of symmetry, which was x equals 1, by not using the graph, but instead using the equation -b over 2a. And what is -b over 2a? -b over 2a is the expression that indicates the x coordinate of the vertex if your quadratic is expressed in standard form. Okay. So since I know that b is -2, I'm going to do the negative of -2 divided by 2a. I know that a was 1, okay? So I'm going to plug that in. Then I'm going to get 2 over 2, which is just 1. Or my equation for the axis of symmetry is just x equals 1 by using -b over 2a because my original quadratic was expressed in standard form. Okay. Then we're going to do one last one, and I'm going to do it under the section right here. If you notice that for problem number 3, this form right here is not in standard form. That's a problem because I can't use -b over 2a. So because my quadratic is expressed in what's called factored form, I have to now convert it to standard form, which will then allow me to use this -b over 2a to get the equation of the axis of symmetry. Okay, so in order to get factored form into standard form, you have to use the box. So I'm going to use the box. And I'm going to write down x minus 3 on the top. And then I'm going to write down x plus 1 on the left and then fill in the box. When I fill in the box, I'm going to get x squared minus 3x x, and then negative 3. Now I can rewrite this factored form as y equals x squared minus 3x plus x minus 3. Then now I want to combine like terms. So now I'm going to get y equals x squared minus 2x minus 3. Great, now I converted this right here, this factored form, into right here, the form that I need, which is called standard form. Now to get, remember the whole goal of this problem number 3, I'm trying to get the equation of the axis of symmetry. That's what I'm trying to do. I already know the answer. It's x equals 1 from the graph. So how am I going to get x equals 1 by just using the equation? Well, I'm going to use that negative b over 2a. So if I did x equals negative b over 2a, well, what am I going to get? B here is negative 2 and the a is 1. Okay, so I'm going to throw those values into that equation and I'm going to get the negative of negative 2. Okay, divided by 2 times 1. That's equal to 2 over 2, which is equal to 1. Or finally, I get the exact same equation as I got before from the graph. X equals 1. Okay, so I did all the work. I'm just going to do one quick summary and then we'll be done with this video. Okay, so how do I summarize what I just did? Remember, so initially, remember the whole goal of this video is to understand how to get the equations for the axis of symmetry. The first option is to identify the vertexes here, here, and here. Okay, that's the first thing. So I identified all 3 vertices. Then after that, the equations for the axis of symmetry are just x equals the x coordinate of the vertex. The x coordinates of the vertex are here, here, and here. And I just threw them all to the right side, okay? And then I'm done. Those are the 3 equations for the axis of symmetry. What else, okay? Then after that, I'm like, okay, I don't want to use the graph anymore. I want to use these 3 equations here, here, and here. The first equation was in vertex form, so that was the easiest one to get. So because this equation here was in vertex form, I can identify the vertex. And the equation for the axis of symmetry is just x equals 2 because 2 is the x coordinate of the vertex. Easy. Okay, then for the last 2 equations, remember there's an equation for the axis of symmetry, but it's only when the quadratic is expressed in standard form. This equation right here, that's already in standard form. So, and then right here, I use negative b over 2a as another alternate way to get the equation for the axis of symmetry. I already know the equation is x equals 1 right here. So you can see that I got the exact same equation, x equals 1, by just plugging in the values of a and b from this equation that was in standard form. Lastly, the last quadratic that was expressed in what? That's expressed in factored form. So then what did I do? I used this box method here because I don't want factored form. I want standard form. So then I got the equation here in standard form. And then I identified my a and my b. My a was 1 right here. And my b was negative 2. And then I plugged that back into the equation for the axis of symmetry. Remember, any axis of symmetry equation is in the form of x equals something. And it's always x equals the x coordinate of the vertex. And the x coordinate of the vertex is always negative b over 2a if the equation is expressed in standard form. So I plugged in my values, a and b, right here. And then I also got x equals 1, which is the exact same equation as I got before from just doing it the graphical method. Okay, I hope this video helped. I try to explain the concepts as clearly as I can. I will see you guys in the next video. Thanks.